So, like I mentioned earlier, that there is a shift in the classical way of, the traditional way of doing security assessment towards AI-based security assessment. Now,
Sorry, Olan, I don't think we see a slide here.
can you see my slide?
No.
Okay, so go back. There. So you should be able to see it now. Yeah. So this is the version I was referring to, the exact version I was referring to. Can you see it now?
Nope, we can't see it.
Yeah,
Oh, I think there it is.
good. So I was trying to give a background about security assessment. So having mentioned the background about the increasing rates of vulnerability across the world. Now the question is, what is vulnerability assessment? Now, vulnerability assessment is a systematic way process through which organizations assess their IT security posture to be able to know whether their applications, their network is vulnerable to attack from anywhere across the world. Now, objectives of vulnerability assessment, which is also called VA, is to identify known vulnerabilities, to be able to measure their potential impacts on the business, and so to also provide remediation strategies for the organization. Now, vulnerability assessment covers things like asset discovery. You need to know the software you have in the system, in your organization, the servers, the systems, and what have you. And then you also need to like perform vulnerability scanning. And this is where we are trying to come in now. Organizations that are required to perform vulnerability scanning, and then the classical tools they use across the world includes tools like Nexus, Qualys, OpenVAS, and to scan their enterprise applications. Now, the third thing in vulnerability assessment has to do with the analysis and the risk evaluation. Now, when you perform vulnerability assessment, you try to like know to prioritize the different vulnerabilities you discover. There are some vulnerabilities that are not so crucial, and there are some that if they are exploited can bring down your whole network. So you perform risk evaluation assessment, and then you also like do reporting to be able to for senior management to be able to take appropriate measures. Now, and the last thing for vulnerability assessment is you need to perform remediation activities, like mitigation activities to be able to uh, like um, correct the patches, like fix the patches to stop the vulnerabilities that have been discovered. Now, I mentioned earlier that there are conventional approaches that have been used in the past, like machine learning, deep learning, but we have this idea that those classical AI methods do not really understand like programming language, because every software-based systems are written and developed with programming language. And if we can train an AI to understand computer programming language, and then to also extend that for the AI model to be able to know what is a vulnerability, what is a safe code, and what is not a safe code, then the LLM-based approach should be able to perform better than the classical machine learning or deep learning that we all know. Now, these are the comparison. We are trying to compare like the existing approach that are used across the world today in the terms of scanning for vulnerability assessment. Now, this one, number 1 to 5, are the top scanners that are used across the world by security analysts to be able to like scan software and then discover vulnerabilities in them. Now, you can see comparing that to like code LLM approach. They are very good when it comes to signature. Like signature means that the characteristics of a particular malware or a vulnerability, those softwares are trained to be able to do that only. But when it comes to like detecting unknown vulnerabilities, zero-day vulnerabilities, vulnerabilities that are not following the traditional pattern, they are not so good in that compared to like AI-based code LLM approach. Now, in our own study, the previous work that has been done, they use machine learning. And then in carrying out that research, they developed like a data set from real life Android software. And we also adopted that approach because Android is one of the most popular software system that is used across the world for mobile devices. So we also approached that. We adopted that data set But instead of using the classical machine learning that the previous researcher did, they adopted, we decided not to use that, but to adopt the LLM approach. And that LLM approach is such that we train, optimize, retrain, fine-tune the LLM to be able to understand source codes of Android-based systems. Now, the previous work, based on what they did, they used three different machine learning algorithms: random forest machine learning, multi-label perceptron, and support vector classifier. And we could see the performance of the method, the classical machine learning method they used. The best performance they got was around 0.92 for accuracy, and then 0.91 for F1. Now, these are the metrics that we use in the AI for classification to be able to determine how good an AI system in terms of performance. Now, in our approach, so we adopted the same data set. And I mentioned earlier that when security experts and software developers discover any vulnerabilities in any software application in the source code, there are standard way of reporting it across the world. And in that standard way of reporting it, you have some of these keywords that are used globally. It's like a global standard that are used across the world that security experts understand. So in the database, we have all of these. Each of those security vulnerabilities are classified. They are given ID. So for our own work, what we did was to like adopt that data set. Those data sets already contain the keywords that if an LLM is trained on that, to be able to like discover vulnerabilities. So these are our research questions. We want to know if LLMs that are trained on programming languages can perform better than classical machine learning. And then the LLM model we adopted, there are two types. There are the pure code-based LLMs and then the graph-based LLMs. Now we use those two methods and then we compare their performance. Now, if you look at the approach here, the typical large language models that we know, they are trained on human language. Now, programming languages approach method that we adopted, they are trained on programming languages, but we extend that to Android source code by fine-tuning the programming language model. Now, so this, as you can see on the screen, this is the existing, the traditional LLM. Now, this is the programming language LLM. This is not our work. These are existing work. Like the previous, some researchers extended the work of traditional language model to programming language. But for us, we decided to extend the programming language models to Android operating system. And so this is the aspect where we are focusing on. And then in our approach, this picture here shows like an overview of what we did, like trying to train Android, and Android is developed with several programming languages. So when we fine tune an Android system on vulnerabilities that are peculiar to Android, it's able to discover any form of vulnerabilities that relates to all these programming languages that are shown here. And these are the two models we adopted: the code bath and the graph code bath. So this code bath and graph code bath, they are trained on programming languages. Then we fine-tune that on labeled data sets of security vulnerabilities that are peculiar to Android. And then this flowchart shows our approach, our methodology. Like we acquire the same data set, we clean the data set, we split the data set, like follow the normal classical way of machine learning, but instead of using classical machine learning, we are using programming LLM-based programming approach. So in our results, this is what we discovered. Now compare for the first programming language model LLM approach we used like about 9 different data sets, just like the previous research that was done. But the difference is such that compared to the previous work where the machine learning, perceptron, the SVC, and the random forest, those classical machine learning algorithms that they use, where they were giving results for like accuracy of like 0.92 and F1 of about 0.91. In our approach, we discovered that when we train programming languages models to understand security vulnerabilities in Android, the performance is much more higher. For example, in some of the data sets we use, we are getting like 0.99 accuracy, F1, and precision. And if you can see the different data sets here, it shows like the different performances of each of those models on the different classes of Android datasets real life Android datasets we use. And this is for CodeBat. Now, the second model we adopted that we fine-tuned is the Graph CodeBat. Now, Graph CodeBat is an extension of CodeBat, but the difference is that Graph data flow was kind of integrated in it by the initial developers of the model. So Graph CodeBat slightly outperformed CodeBat in detection of security vulnerabilities in Android source code. Now, in our conclusion, we have like three research questions we are trying to like answer. And the first research question is we wanted to know if programming languages models that are trained on Android source code vulnerabilities could outperform classical machine learning and deep learning models. And we discovered that we're able to confirm that fact that they outperform the classical machine learning models that have been used, like deep learning and what have you. Now, comparing the two models that we adopted, the pure code-based LLM and then the graph-based code LLMs, we discovered that the graph-based LLM slightly outperform the code-based LLM. And what does this mean? What it means is that for security experts that want to adopt AI-based approach in training a model to discover vulnerabilities in software systems, we recommend both CodeBat and Graph CodeBat in their work because their performances are very close, even though Graph CodeBat slightly outperform CodeBat. And what this means is that compared to like classical techniques that are used in the industry to discover vulnerabilities, adopting this approach means new vulnerabilities that we don't even know about, which are called zero vulnerabilities that people in the industry fear so much because a vulnerability that you don't know before can be exploited by hackers to cause a lot of damage to your organization. Now, when you train an AI model, the AI model will be able to extend that capability to a vulnerability that was not part of the data set that was trained upon, because AI could discover new patterns that classical vulnerability scanners could not do. And this is the reason why this method is, we are kind of recommending this method to organization. And to be honest, it's not limited to just Android operating system alone. We train on Android code base, but if tomorrow we get like data sets for Mac or for Linux or for iOS, we're still going to get the same kind of results. But what this study confirms is that you can extend the capability of large language models that are trained on human language, which has been extended to programming language, and which we are now extending to specific software-based systems like Android. You can train them to be able to discover vulnerabilities in their source code. And those are the things that we believe answers our research objectives.